Okay, let's start. Yeah, we want to show today some features to solve some common PKI problems. My name is Michael. This is Alex. We will split the presentation in two parts. I will do the first. I will do the first part of the presentation, a little bit theory, some concepts, and then Alex will show you some practice. I think some demonstration or a playback. It's perhaps a better word, not demonstration. It's a little bit too risky here to make some real presentations. And yeah, let's start. I would talk about, like I noticed, about some concepts from us. I would talk about PKI reans. It's a little bit, yeah, the word is derived from Kerberos reans. I will a little bit show you about crypto abstraction, only very short here. Then I will show some stuff about configuration inheritance, and finally about workflows. Okay, what is one of the most critical aspects in PKIs today? This is CA migration. For example, in our university, it's the Humboldt University here, 2 kilometers away. We have the following architectures. We have a root CA. It's a common system from the DFN PCA. It's operated on OpenCA. The intermediate CA, it's the same. It's our root CA, and then we have the end entity CA, which issues user certificates and server certificates. The interesting thing is that this intermediate CA here only issued one certificate in the whole lifetime, the end entity CA certificate. This is a little bit stupid, and so what makes migration meaningful is we have now only a root CA. Okay, we have also now a real change in the root CA because we have another PCA here, and we have only our end entity certificate. CA here below. The thing is, if you look a little bit closer to the system, then we have two things. We have here some root CAs on top, and below we have some end entity CAs. The intermediate CA here is completely useless. But the interesting stuff is that we have two end entity CAs, but they are completely independent. This means we lose a lot of information. So we know here things about certificates. We know some things about certificate requests, which users do these requests, and here below, after migration, we start again in common systems. Another very useful example are mergers. Mergers are very common today. Even big companies are bought by much bigger companies. And so you have always CA migrations, even in very, very high volume environments. So a standard environment is that you have an alpha bank CA. It's only an example here. This bank doesn't exist. And you have a root CA provider at a low level. This brings a lot of stuff in the world because this is very common. Many banks, even small banks, or most big banks have big certificates, small banks have small certificates. In this case, they often use low-level verification. Bigger banks, in this case, for example, a Zulu bank, often issues root CA certificates by themselves to be really secure. There's a not a really standard, but it's called Perl. This is private isolated root mutual authentication. Slow. Okay, now better to understand? Okay. Okay, if I'm too fast, then... Okay. So what is a merger? A merger is nothing else than these banks come together and build a new CA system. One of the most common things in this situation is that they search for a new root CA provider to meet the requirements of the alpha bank below, and the result is that they have a very, very high secure root provider and a normal end entity CA below. The problem here in this situation is that you have a root CA area here, and you have an end entity area. But the problem is the Zulu bank itself is a root CA, so you have problems with the inheritance. The other thing is, of course, you lose a lot of request systems. So, what we can summarize from this, if you have a merger or rollover or whatever, you never want to lose certificates and you never want to lose requests, because all these events mean you lose information, which is really, really important. Another thing is, from time to time, there are new releases of software, especially in the CA environment, or big companies are no longer present on the market. A big example is Baltimore. I don't know. Who knows Baltimore here? Okay. Perhaps only for your information, Identrust was a big, or is it is a big banking PKI infrastructure. Perhaps around 50% of the banks and the root CA system is equipped by Baltimore, but Baltimore no longer exists. So the company is now an offshore company only to make money, but the company's software itself is sells, and now the company no longer exists. You can buy some support, but the company in practice is no longer on the market. But they equip 50% of the banks. So another thing is how to import a PKI. Sometimes it's necessary to simply import a PKI or the certificates of the PKI, not the key. But sometimes you go and you say, okay, my partner has a PKI system and I need all of them certificates in my system. In this case, you have to import all these things. And sometimes later you say, okay, I buy my partner and then I need the root key. This happens in practice, okay? But sometimes you simply need a playground. This means in PKI systems, it's really important to have test environments in the production environment. This means that you really can test what you are doing before you do it, but with the production system. You usually don't want to try things on your notebook or on PC, and then you go to 100 or 200,000 persons environment. And then let's look what's happened. So what's the idea behind? If you first look, you simply need some isolated CA systems on a system if you want to play with multiple CAs. But what happens is you have some more user CAs or intermediate CAs or whatever. In this case, it's a really good idea to start grouping or building domains. And what we are talking here about PKI realms is nothing else than this. It's a namespace. So okay, here it's written as a sentence, but the only thing which you have to take in mind is that the PKI realm is a namespace where you can place stuff. Every type of stuff, even multiple CA certificates and keys. So the next important question is how you link certificates. The important thing is that in your system, every certificate is only once present, even if you use it in different contexts. Perhaps you have a CA certificate, but the CA certificate was issued by root CA. This certificate should only be present one time in your system. It's never a nice thing if a certificate exists twice in the PKI database. So what we are doing is we simply issue a certificate and we reference then by a SAH1 hash of the issuer certificate. There's a small problem with this definition if you use cross-certification, because we don't cover this at the time. We have defined paths if we want to go to the top. But in practice, or the customers which we have, or in the environments in which we work, does not use cross-certification today. And the last statement is every certificate is only a member of exactly one PKI realm. Perhaps you now say, perhaps I need the certificate in 2 realms. In this case, there's a solution which we present some slides later. So okay, what does this mean in practice? In practice, you have simply 3 certificates, and here's the realm, the gray stuff around. What happens, you have a user CA. In this case, I don't know, is this, okay, this should be green. Okay, I see here it's not really green, but it's green. This means it's a certificate, so you have a simple reference, which you can go up until you find the root CA. The important thing is that I noticed, okay, you have another reference, it's not important. Some slides before, we noticed that we can import several other CA systems or PKIs in one system from us. The reason is simply, you see here, there's perhaps another trustworthy CA which you need in your system, but you don't have the private key. A good example at this situation is, it is often that you have operators which have very, very high secured certificates to authenticate, and then they issue very low-level server certificates. In this environment, you don't own the PKI system, which issues the operator certificate, but you must fully import the other CA system without the private key. So some additional implementation is Sugar, which you will see later. We have aliases, which are simply only names for certificates, and you have some special CA certificate handling. So what's going on in practice? You often see these gray boxes. Oh no. Okay, the colors are not very, very useful. In this case, the gray stuff here, the rectangle, this is our PKI realm which we defined. The round box here, this is the CA system and the rectangles here are the normal certificate. Now we have so-called aliases. This OpenXPKI CA in this case is a CA certificate, but not the real certificate. It's only an alias, a name, a reference. Where we can find the CA certificate. The CA certificate is present, like we know, in only one PKI realm, like defined. In this case here, this is the real certificate. It only exists one time. We place certificates in the CA or in the PKI realm where we issue them. This means if you issue a CA certificate, then you will find it in the CA or in the PKI realm where you issue it. You don't find it in the CA system where you use it. There you only find this reference here. So it's some type of logical abstraction. And here, you see here the OpenXPKI CA was issued by root CA. And now you see this, what we call a special CA handling. We have a realm with an empty name where all root CA all self-signed certificates are placed. A self-signed certificate is not issued by a real CA system. Therefore, was there a question? No? So this is the usual system which we have. This means we have some levels of groups or domains. What we show you now is how flexible the system is. So what you can see here is this is the typical system if you have a real root CA. Perhaps you have some user CA, some server CAs, which you will manage by different operators or with different security levels in this case. Okay, we talked some time ago that we can do things which have nothing to do with real cryptographical stuff here. Only short to show you how flexible this approach is. And don't try this at home, especially don't try this at work, because this is absolutely not standard compliant what you see here, okay? It's only for demonstration how flexible the concept is. You have here one CA certificate, but you can use it in different PKI realms. Theoretically, you can issue here certificates 1 and you issue here a certificate 1 with the same CA system and issue different CRLs with the same private key. So this is nothing which you should do in practice. It's only to demonstrate you at a very low level what we can do with this definition. So here is nearly the same system if you try to emulate an immediate CA certificate, like you see before. Okay, this is the graphic which matches what you see at the first slide, where we say we talk about CA migration. If you remember, we have a level which we want to eliminate. And here you have a root CA level here, you have the intermediate level which you no longer need, and you have here a normal CA level. The important thing is, in our database and our normal application, that the certificates which you issue here, you see these certificates even here. You can simply handle them on the same surface. Okay, on certificate level, it does not make much sense. You see, okay, another CA issued another certificate. You don't need this information usually. What you need is information from certificate requests. So, which information we have in certificate requests? We know which user makes the request. We know when we identify them, when they were present in our infrastructure. We have a lot of information from the first approval of the certificate request. And a feature which is usually not used because it's a little bit too risky from the cryptographical point of view, you can simply use the requests which are present in the old CA system and use them in the new CA system. This means you can take at this CA as a request from the first CA and issue here again a certificate. This means if you have renewal processes where you reuse old keys, which is not recommended, okay, but even if you generate new keys for this, you can use the information from the first approval process. This is important if you try to make rollovers, but with all certificate requests. So, this is the first part about PKI realms. Crypto extraction, I want only to talk very short about this theme. You have often different toolkits. You have OpenSSL, you have OpenTLS, you have NSS from Mozilla. The problem is that you have customers which don't want to be limited to one toolkit. You give them a toolkit, you say, okay, we use OpenSSL, which is our default toolkit which we use. But often these customers say, okay, we want to have an alternative if OpenSSL changes the license or will no longer be supported. And therefore we have a crypto abstraction where we can change the algorithms, where we can change the toolkits. Algorithms means we can also support proprietary algorithms because we can exchange toolkits. The Ghost algorithms are nothing else than another word for Russian algorithms. In Russia we have the Ghost, in Germany we have DIN, and the Russian government enforces the use of algorithms which are specified in the Ghost specification. This means if you want to introduce a PKI system in Russia, then you can only introduce cryptographic algorithms which are supported or allowed by Ghost. It's not to break in, these specifications are not used to break into these algorithms, but the Russian government don't trust Western researchers, and so they specify their own cryptographics. This is really interesting because often it is exactly the same cryptography, but explicitly you can only use these algorithms as if they specified in Ghost specifications. So Ghost is nothing else than DIN. But we can it's implemented and it works. We can even issue certificates with OpenSSL but with Ghost keys inside. So another interesting issue are different protection classes for used keys. Usually big companies use HSMs, but for a university like my university, it's simply too expensive. So you can only use soft keys, but at soft keys you have the problem, for example, how we do M out of N passphrases. And even this is possible if you use software. But we have a very, very fine granular mapping for the security. You can even enter hard-coded passphrases in our configuration if you want it. Okay, it's not recommended, but for some test cases it makes perhaps sense to have a hard-coded CA passphrase or no passphrase. And the last thing, like I noticed, hardware security modules, because this stuff works in very different ways. You never know what they really does, but they are secure, okay. The interesting stuff is that nearly every hardware device vendor has another system how their modules work with OpenSSL. If you think, for example, engines are standard, then you can look at Luna devices from or Encipher devices. One guy simply patches the toolkit and then it works, okay? And the other guy simply put a complete shell around the OpenSSL toolkit and runs the OpenSSL toolkit in a shell box. So, okay, it's not nice, but it works. Like I mentioned, I only want to talk very short about cryptographic abstractions because it's a little bit difficult and it's not very nice to present in so short times. Another feature which was often requested was configuration inheritance. The common problem in configurations for CA systems is that we have very, very small parts in the configuration which really change. Usually you have to change some information for the private key, for the name of the CA system, but the most information, if you have a PKI introduced in your company or university organizations, are statical. The organization name usually not change, the country or the domain encoding does not change. The most institutions which you have will never change. So you never have to change the configuration for an interface or for logos or for paths in your configuration or even for databases. It's very rare that people suddenly change their database systems. If they decided for Oracle, then they use Oracle for every time. If they use Postgres, then they will use it for the next 10 years, hopefully. So you have many repetitions. The next thing is, if you create a new CA, you don't want to make mistakes. So what you are doing, you copy. You simply copy the whole stuff and you try to make minimal changes. And usually you forget something. And the final thing is, you have a basic configuration and you have only to do very small local additions. This is the idea behind the configuration inheritance. So, how does it work? We have simply an XML configuration for the full complete system. We have no other configuration except for the logging because we use a module called log4Perl. It's the same thing like log4j from the Apache software project. All other stuff is configured in XML. Here we have a so-called attribute idea, which nothing is else since a simple name for a node to identify a node 100% unique. This makes sense if you have, for example, long lists for extensions or other stuff which should be included in certificates, and you have to identify parts of the configuration. And we have a so-called node super. We only use this name because the attribute was never used by another part of software, and this is the path to the parent. It sounds a little bit difficult, but it's really easy to use. how it looks in practice. In practice, you have a configuration, in this case called the common configuration, and you have a part from the configuration which is called test. And the idea of this part of the configuration is default. So what is present here, it's only a value called myTest. What happens now? Happens now is that we have a very, very deep placed configuration part, and we have even again a part which is called test. You see here, we don't specify any value here. We only specify here a path where I can find the information which usually placed in the tag test. So here you have to go one level up. You have to go into common, you go into test, okay, ID default. It's not really necessary, but we know now if you look for a value which is called deep test value, then the software know, okay, I have to take this value. The important thing is that you can mix the stuff. For example, you can include here another part of the tag test which is called, for example, second value. And you can fill in a value which is called second value and the full name, then the second value is detected and used, even if here's a reference, so you can mix this stuff. This is a little bit useful if you work with extensions and only parts of the extensions change. For example, if you want that the subject item is a part which usually should be entered by the user, but for example the DNS name or an authoritative email address should be constant, then you can mix the stuff here. This is very useful in migration environments. And we have a second way how you can use it. You can also use absolute paths, so you can start here from top, go into common, go into test, and here you see we have no default value here, because really simple, we have only one value test, so it's 100% unique. Okay, let's move to the last stuff. We don't want to start with too much negative impressions about PKI, but what is the most common problem with trust center software? If this is perhaps too negative, okay, we can start with another word. We have very, very cool demo systems, but we have problems usually. What are these problems? Problems usually occurs if you start to look for customizations, because nearly all systems on the market look for, or even OpenCA, the old system, expect a special workflow. They think they have an RA, they have perhaps a batch operation, they have some approval operations, but if you start to need customizations, perhaps you have another approval way, you have two approval ways, it's okay. Then you got into trouble, because you have to modify the workflow, and the workflow is usually hard-coded, even in batch systems. The other thing is that the most companies, organizations, even if you want to work with students, you have large databases where all identities are known, and you don't start from scratch. Usually you have a big personalization database, and you only want to adopt this database without too much work. So, and the easiest way is if you have a presentation from a trust center vendor and then you sit down, the bosses looks very pleasant, and after a while they simply, okay, my business process is the following, simply integrates them. And usually these operations fail. So, the simple conclusion is the horse begins if we start with customization. So, what we can do, like all big systems which are developed today, we have a server. This is no surprise. Like the most other servers, we have a context. In this context, we have the XML configuration. This is the part which works with the inheritance. We have DBI. Perhaps you have to notice we use in the complete software stack Perl. We have some low-level stuff which is implemented in C, but the most stuff is implemented in Perl. So DBI is the database interface, which is a little bit modified, but it's the standard interface. We have some session handling, and we have a crypto abstraction, so nothing difficult. Additionally, like the most systems, we have a server API, and a server's API makes no sense without clients. Now, we have a workflow API, and now the thing will be interesting. Here we have the so-called workflow module. The workflow module is a standard CPAN module. You simply can download this on CPAN, which is highly configurable. It's not standard compliant with VFPDC or something. It has an own configuration. The advantage is that it's a very simple configuration. And the advantage for us is that this is all hard-coded, what you see here. So you cannot change the server API, you cannot change the workflow, you cannot change the modules, you cannot change the context. So it looks a little bit statical. The interesting stuff is, here for PKI systems, so that all the other stuff, so this means conditions, validators, activities, and even the configuration for the workflow system is configurable. If you roll out an OpenXPKI system, or you simply download it, then you get a default configuration. This means we have a personal idea how you should manage a PKI. This means you have a database, you have, okay, here a database interface, you have some tables, and we have an idea how you should handle requests or how you should generate requests. But if your expectations does not match our idea, then you can change the complete workflow. In this case, I think, I don't know how many workflows we rolled. I think we roll out 6 different workflows, and perhaps in the future 7 or 8. The simple thing is that it's only a pattern for everybody. So we don't know what SAP has for a database in R3 or what Oracle has for databases in their human resource systems. We can only say, okay, we support ELAB, we support some databases, and we simply use it. But of course, you can create your own workflows. I think you will say something about it. Okay, how does this design help you? I don't know it, but Alex will give you some overviews about it.
Mic working? Yeah. Okay. Hi at first, I'm Alex. While my Mac is still doing stuff here, I might as well introduce myself. I graduated in mathematics recently, and I work for Synops, which is a small. Yeah. I work for Synops, which is a small network security engineering. That was too close. Better. Okay. Better now. Okay. So I work for Synops, which is a small network security engineering company near Frankfurt. Yeah, we're one of the core developers of OpenXPKI. And one of our customers is a large financial institution who will be deploying OpenXPKI in February, or end of January actually. There we go. That's the end. Sorry. Okay, so what I am going to talk about is a bit more practical than all the theoretical stuff Micha was talking about. I'm going to show you a bit more about workflows with the example of the certificate request workflow, which is one of the standard workflows which we already ship. Then I'm going to talk about a bit about SCEP, which is the simple certificate enrollment protocol, which is a protocol which you can use for routers, for example, that they get their certificates automatically. Then I'm going to talk a bit about smart card personalization, which is one of the nifty features we recently built in. Yeah, I'm going to talk a bit about support, how you can get that. And of course, we always want to make a bit of, we always want to have some new developers, and if we are lucky, somebody might get interested in helping us out. So there's a bit of hackers wanted as well. Okay, so there we go. Certificate request. First of all, I don't know how many people of you are familiar with CA systems, so I'm going to show to you how it looks from a user perspective first, and then I'm going to delve right into the details of how the workflow actually looks like. Okay, so the user basically uses the web interface. There's one of the clients that Micha was talking about. So basically the web interface implements a web client that talks to our server. And the user can actually do either a browser-based request. So if he's using a Mozilla-based browser or Opera, for example, then he can do this using SPK-C. Or if he's stuck with IE, he can use the external ActiveX control, which comes with every Microsoft Windows system. Well, if you're keen to, you can also, of course, upload your own PKCS10 file, which is for the more exotic cases, I guess. Or if you can't do either, there's always the possibility of doing the key generation at the CA side. So basically, the CA can generate a key for you as well, if you like. So let's have a look at how it's looked like. Okay, So basically, I've skipped some of the parts, but this is the basic process that the user goes through. So he can choose a certificate profile, which will decide how his certificate will actually look like in the end, what extensions are set, stuff like this. Then he can select the type of key generation, which was what I already talked about a bit. So you can do browser-based, PKI 10, and so on. Then, of course, you have to set the name of the certificate, which is basically the subject of the certificate. Here you can see, if I get the pointer, here you can see that, of course, you can configure this to set your organization, for example. So basically, you want to have all your certificates contain your organization if you deploy them somewhere. So what else can you do? You can always set subject alternative names, which is something that is not as widely used as I guess it should be. Something like when I look at server certificates, or self-signed server certificates all around the web, especially in the chaos area, all these are signed for *blahfasel.de. So there are actually subject alternative names where you can put your DNS names of the real machines. Of course, you have to be, you don't have to be lazy, so you have to put all the DNS names in there, but you can do that. And it would be pretty helpful because that would be one less browser warning you get. So basically, that's like HTTP 1.1 is compared to HTTP 1.0, subject alternative names to no subject alternative names. So that's my little rant about subject alternative names. Use them more. And of course, if you use OpenXPKI, you can get them for free, as you see. And this is what you see if you use the SPKC-based request. So basically, you can just choose the key length here, which is a built-in dialog from Firefox here, and then your key is being generated on your browser. Also, it says that this might take some minutes. This only takes some minutes if you've got really, really, really slow hardware. So this is really fast, and then you've got a certificate request, which is sent to the CA, and then all the fun starts for the CA side. But basically at the browser side, you're nearly finished, and you just have to wait for the CA to sign your certificate, and then, well, you can install your certificate, and it will be in your browser store, and you can export it to PKI 12 or do whatever you like with it. So that's really nifty that you can do it all within the browser. Okay, so how does this look like? Okay, I expect nobody to be able to read this. It's just for the structure. So this is how the workflows actually look like. Like Michael already mentioned, this is basically a state machine. So you've got... Okay, I'll try. The mic keeps going down there, so that's a bit annoying. Okay, maybe this is better now. So basically what you have is you have got states, which are these small boxes around here, and you've got activities, which are the things in between. So you can move from one state to another with an activity, and you can only do this if a certain condition is met. So what else is there? Something that will be in pretty much any workflow, or not in any workflow, but in many workflows we have, is the approval part here. So you can see a bit more detailed in what is going on here. So basically you can approve CSRs, and you can cancel the approval. You can reject the CSR, you can reject it from here as well. And basically you can have as many approvals as you like, and you can configure how many approvals you need, or how many approvals you need for a certain type of certificate. So if, say, somebody applies for a CA certificate, you probably don't want, like, okay, somebody clicks approve and then he has got a CA certificate. So you can actually decide how that is checked, and you've got the condition here for the check CSR approval. So basically the CSR can only move out of the approval state if, well, all the conditions are met that you specify in the condition class. So, well, down to the core a bit. This is how it looks like in the XML configuration. Well, basically, except for it being XML, I think it's pretty much readable. I mean, you've got states here, you've got actions. Well, basically, they are called actions because that's what the name in workflow, the Perl module we are using is. We call them activities. And we've got conditions. So basically, all you can see here, these are symbolic names, and they maps to some kind of Perl class that actually executes the activity or checks the condition. So this is actually how it looks like in Perl in an activity itself. So you just have an execute sub And then you can have a context, so every workflow has a context where the data concerning this workflow is stored. And you can, of course, modify the context to retrieve some data from the context, store it into the database, and well, write something back into the context. So this is pretty useful from the abstraction kind of view. So you basically deal with the workflow context in each step, and you modify it, and then you end up at a different state, and you can do something else, and you can move on. Okay, well, so much for workflows right now. I guess that pretty much covers it from the top to the bottom. A bit about SCEP. So SCEP. SCEP, well, I'll just make a quick check. Who has ever heard about SCEP in this room? Well, more than I would have thought. Okay. For those who don't know, SCEP is the Simple Certificate Enrollment Protocol. It's currently an IETF draft, which has been initiated by Cisco. So they were the driving force behind that. Currently, it's expired. I think it expired on December 2nd or so. There's not a new version yet, so if you really want to read it, you have to use the Google cache. That's a bit annoying. And basically, it's a protocol to automatically enroll for or renew certificate. So if you have like an embedded machine, a router, a VPN gateway, something, it might need a certificate, how to get it on there. So basically, this is what SCEP is about. SCEP can talk to the CA and say, okay, I'd like to have a certificate, please, or my certificate is running out, I have to get a new certificate. So how does it look like? Basically, well, it's PKC is 10 wrapped and PKC is 7 over HTTP. As said, so it could be worse. I mean, people could have gotten worse ideas. Basically, one of the things that's a bit annoying is that the error codes are a bit nondescript. That's one of the bad things about the protocol. But all in all, I guess it's a pretty decent protocol. Yeah, and it's implemented in many hardware devices, not only by Cisco, but by lots of other people as well. So basically, even though it's a draft, it's pretty much ready for production. All the people are using it already. So why are we doing it actually? Why do we want to have it? Well, the alternative is doing it manually, which is, well, not an alternative actually. So you have to request a certificate. So for example, you have to use the web interface. Somebody has to get the certificate from there and, well, install it on the device. Note the expiry date somewhere in a calendar, maybe a digital calendar, maybe like even a paper-based calendar. And then, yeah, you have to already remember that you have to request a new certificate come the expiry date, or preferably before the expiry date. And you have to install that again. So you have to repeat that, you have to don't miss mistakes. And if you have got a lot of machines, that's basically not practical. So it's pretty unsuitable in larger installations. Okay, so I'm going to talk about a bit how it looks like from the user perspective. I'm afraid that might not be really readable. It's not really that important that you can read all the details. Basically what I'm talking about is SSCEP, which is the standard Unix tool for speaking SCEP. There are some more free software tools that can do that. Actually, there's one Java-based tool, but I don't know anybody who's ever gotten that to run because it's based on a really, really old Java version. So if anybody of the people who just raised their hand on SCEP has gotten Java SCEP to work, I'd be really interested to know. So basically, what do? First of all, you get the CA certificate from the SCEP server, and of course, then you verify the fingerprints out of band, please. Because, I mean, otherwise somebody might just sneak an SCEP server on your ass. So you have to do that. And then you can just send your CSR to the CA. Basically, you generate a key, for example, using OpenSSL, and you generate your PKCs 10, and you pass it into SSCEP, and SSCEP sends it on to CA. Well, you have to wait for the approval, so you get a pending response back, which makes fine with our workflow module. So basically, the workflow we start here is then in state pending as well. And if something happens, then it might end up in state success, which is when you are done, you get the certificate back, the certificate is installed. Okay, more scary workflow pictures. So this is how the SCEP workflow looks like. Actually, it just looks scary from the outside. If you actually wanted to implement it, that's how we started. We just drew the picture of, okay, what happens in which state and how do we decide if this is a renewal or not and stuff like this. So it's actually pretty nice to design it that way. And that's what we did, and then we put it into an XML file, we printed that out, and we, drew some more lines, and well, we have to change that and this. And that's pretty nice about using workflows here. And the good thing is that we can reuse stuff as well. Well, this looks familiar, well, maybe not from that point, but from here, it's the same approval code as before. Because basically, you might want to have an approval in SSAP as well. So we can just use the same code here, or we're using the same configuration as in the normal certificate request file. So that's pretty useful. You can see a bit about workflows are useful for actually reusing code, or actually reusing configuration. Okay, shortly a bit on alternatives. Nobody actually wants to do that, I guess. PKIX CMP is the certificate management protocol, which has actually been standardized in RFCs, but it's not really in wide use. The only people I know of that have implemented that are actually the Baltimore people who are, well, you heard it, gone, and the Novosec people have implemented in their bouncy castle Java cryptographic service provider. So that is actually being used by another open source CA project. So these are the only people who have actually ever implemented that stuff, because it's really, really complicated, and it covers all the certificate management issues, not only applying for a certificate. So the other thing that is there is CMC, which is certificate management with cryptographic message syntax, which basically is a superset of PKCS7, and it's used in S-MIME as well, or it comes from S-MIME. It's standardized as well, and well, the problem is that there's no transport defined. So basically, somebody just chooses the transport, and of course, Microsoft just chooses COM-DCOM as a proprietary transport, and well, that sucks a bit. Because we would really like to see support for that, because that would be just easy to replace a Microsoft CA for domain controller enrollment, because the domain controllers are just enrolling using that protocol, and you could just stick a box and say, okay, this is our open source replacement for Microsoft CA. That would be really neat. So basically, the protocol is pretty nice, and it could be implemented. The problem we are having is the COM-DCOM part, which free libraries for COM-DCOM are a bit, well, scarce, I guess. So what else is there? I was talking a bit about automation as well. We can do SSAP automatically even a bit more with a little helper program called CertNanny, which is another open source program, kind of a sister project. And the idea is basically you install the program and you forget that you ever have to re-request certificates, because you could just run it in a cron job, and if your certificates run out, it just runs out and says, hey, I have to request a new certificate via SSAP, and I can modify the key store. So basically, it's available on a lot of platforms, some really weird ones as well, and more weird ones coming along on the way. You can modify OpenSSL keys, PKCSH, Java key stores, GSKit, and a certificate store. So that's pretty much nearly everything everybody uses, actually. PKCS12 is missing, I guess, but more or less this covers a lot of software that actually uses certificates. And it's widely deployed within a large financial institution. That's basically everybody who ever gets a certificate for a server. We just ask them, have you ever installed CertNanny yet? And if they say no, we just say, why not? Because it will solve all your problem. And well, basically, you don't run into a situation where your certificate expired and you call us and you say, everything is going to hell. Because that actually happens sometimes. Not only within the organization, but with other organizations as well. Okay, next topic, a bit about smart card personalization. What do we need smart cards for? I guess you all have got ideas for what we need them for. What, well, our customer actually needs them for, what the ideas there are is smart card logon, well, a bit boring. Wireless LAN authentication, which is pretty neat, I guess. You can do the authentication using a smart card. And the most important topic here, or the most current topic, is file server encryption, because, of course, you're doing outsourcing. Of course, everybody does outsourcing, you give away your file servers. This means you're giving away your data, which is a pretty bad thing, especially if you give away your controlling or your human resources data. People don't really want that. So especially audit doesn't really want that. And Well, that's where it starts to think about file server encryption. So basically you're giving away the file server, you're doing encryption on the server, you don't care what the people have access on, because basically you're keeping the keys in your organization. So that's pretty neat. You can do the authentication for file server encryption, which is a project we are currently working on. Yeah. Of course you can do encryption as well, or email encryption, for example, but you always have to think about key recovery, which is a real hassle. So that's something you should really, really think about before you start. Okay, so why do we want a self-service personalization application? Well, you want to get a huge set of smart cards, huge bunch of smart cards in a working state. Well, the option you have is either you do it yourself or you let the users do it. Well, I guess that's an obvious choice for everybody in the room. So of course you let the users do this. And it's pretty easy for the users actually. So the user only needs an Internet Explorer, some smart card drivers, and some time. Well, this is something I'm going to show you in a little video. I hope that works. Okay. So basically you just sign up, log in, and then you get here, and you have some kind of data there, which actually comes from an LDAP directory, and which is the data which we are going to put into the certificate, or actually you can put parts of that into the certificate if you like. And then the user just has to click create certificate request like he just did, and will wait an awful lot of time because smart cards are really, really, really slow. This actually takes like around 45 seconds with one of these little thingies. I don't know. Actually, this was not a smart card, it was the RSA security token, which I've got somewhere, but yeah, it was one of these little toys. And this takes about 45 seconds, so I'm just rambling on about. So basically what it does, it creates the certificate request on the device itself, and then it sends it to the CA, which will happen in a few seconds. And then the CA gets that. Of course, it creates a new workflow because we're all working with workflows all the time. And then it actually, depending on how you set it, it's a configuration issue. Here you can see your certificate request has been approved already. And it's currently being processed. It takes another 15 seconds to go to the installation page. This is something that you might consider doing or not doing. It really depends on how you did your authentication. I mean, you might not want to offer a certificate to somebody who just authenticated to using a weak authentication. If you have strong authentication, you might just think about automatically approving the request and generating the certificate on the fly, which has the advantage that the user can install the certificate, which has already been triggered here. This takes another like 20 seconds or so, and then we're nearly done. So this actually worked, and we have a working certificate on the device, which will be shown here a bit. So unluckily this is in German, but I guess you can see that this is the certificate manager, and that this is a certificate issued to me by the local test group dummy CA2, which is one of the development things, and that the subject has actually been used from the LDAP directory, which you can see here. Yeah, so basically that's everything the user has to do, which I think is a pretty neat thing. And so much for smart card personalization. So we are already at support. Well, I titled it, If Reading the Fine Manual Doesn't Help. Luckily, the fine manual is not yet finished. It just has been started. But even when it is, as you might have noticed, OpenXPKI is still quite a complex piece of software. Of course, we have got a mailing list. All of our development takes place at SourceForge, so the list is at SourceForge as well, where all the users are encouraged to ask their questions, post their feature requests and stuff like this. But of course, well, shameless plug here, of course we offer commercial support as well, and if you want to do a deployment, we're here to help as well, so that works as well. And of course, the commercial development is what pushes this open source project again. I mean, I have to say that at this point, I mean, there's a lot of money behind that from people who actually want to run that, so that's where it comes from. Okay, well, hackers wanted. Hackers, that's you in the audience. We want you. If you know a bit of Perl, that would be nice. We're always looking for more developers. Of course, we're looking for feature reporter. Of course, we're looking for bug reporters. There might be the odd bug in there, of course. I mean, sure. So we're happy about people who report bugs, really. I mean that. And of course, we're looking for people to write the fine manual. I guess I'm just kidding here. yeah, I guess we have to write that ourselves in the end. And we're looking for code auditors. I know that they don't, well, come from nowhere as well, so I guess we have to do a bit of that for ourselves as well. But if you like to have a look at open source code and find a bug, be happy and do that and report it to us. We'd be really happy to help you out there. And we're looking for use of hardware that talks SSEP. So if you got a box around that says, okay, I'm SSEP compliant, talk to me, or talk to us on the development list. We'd really like to see how the hardware behaves in that case. I've tried it with a NetScreen device a bit. That was pretty much okay for the initial enrollment. The renewal had some kind of problems, and I would really like to test it with different hardware devices. So that's the development list where you can post development-related questions. And yeah, we're already done. Questions, comments, confusion. I guess a lot of confusion. Now is the time to ask. But if you like, later is fine too. I'll be here all the time, I guess. Just call me on my DECT, 2412, think Christmas, or drop me an email. Michael will be here part of the time as well, or drop him an email. Or of course, mail us on the development list. And thanks for your time. And we got some few minutes left for questions. Are you all shocked? I guess we just bored you to death. Yeah, do so. Huh? Are we? Sorry again.
I was missing it.
Sorry. Ich glaube, es geht jetzt.
It doesn't have a
It should work now.
OFF button. Sorry.
It should be working now, I guess. Yeah.
Yes, everything I said, I already said. I was missing a political remark, and if you would have said it, you would have gotten more questions.
Okay.
Okay.
I was wondering what that political remark would be.
Well, you should have done it.
Okay.
What about plans about an ITsec certification or something like that?
An IPsec certification.
Yes, for ITsec, some level. For
Oh, if you find somebody who can pay the the audit, we'd be really happy to do that. But
yeah, but if you tell that this is used in larger companies, then
Yeah.
it might be the next future.
it might, but I guess even there, nobody will be paying for it. You need a mic for the.
At this point, could be a 542 certification, but that would be, as said, a very expensive certification like ITsec or
Yeah.
ComCriteria, and that would be very expensive. I know that my colleagues of mine are working in the US in a certification laboratory.
Yeah.
So
It would be really, really
open
interesting to
source
have
is
that, of
in this
course.
part,
But yeah, it's an open source project, and you'd have to find somebody to finance that. And I don't really see that in the near future. It might change. Might. Okay. So if no one has any more questions, enjoy your rest of the evening.